Class, welcome back to CS 143, Intro to Data Structures. We are continuing Chapter 11 of Building Java Programs, talking about sets and maps in this video. And so we're going to be talking about, we've already talked about lists in the previous video, and now we're going to be talking about sets. We're going to go over the basic concepts, look at the two implementations, TreeSet versus HashSet, and look at set operations. And we'll take a look at some PracticeIt problems. Then we will take a look at maps. We'll look at those basic operations. We'll look at how you look at the maps, their key sets and values, and look at their two implementations, tree maps and hash maps. And I'm presenting sets and maps together because they are tightly related. Maps use sets, so it's a good idea to take a look at them together. So we've looked at array lists and linked lists. Those are both great for various reasons, especially if you want a fixed number of items. An array is useful. If you want a fixed, an expandable number of items, an array list is good. If you want to be able to insert and delete items out of the middle, then a linked list is good. But looking through those lists for a particular item, say you're searching for the name John in a bunch of strings, that's very time consuming because you have to go and you have to check each item in the list. And another problem is that there's no easy way to prevent occurrence of duplicate elements. And sometimes that's useful and sometimes it's not. If you want to allow duplicate elements, you have to go look at array lists, linked lists, and arrays. So anyways, set is a data structure that is useful for these couple of reasons. One important thing to reemphasize is that sets cannot contain duplicates. There are two implementations of sets in the Java collection framework. One is the HashSet and the other is the TreeSet. And we're going to be talking about these two types of things, hash and tree, for both sets and maps. So it's a good concept to get a handle of. The most important thing is that really hash sets and hash maps, that's the default you should be using unless you have a special need. So hashing is a very fast way of looking things up. Unlike the array list and the linked list, you don't have to search through every single item. You can actually use a mathematical function called a hash function. You may have heard that term from the Bitcoin terminology. Bitcoins also use hash functions. But anyways, hash functions allow us to look up an item very quickly. The drawback of using the hash set is that items are not stored in any particular order. In fact, you can't even get items by index. You can't do that. Tree sets, on the other hand, are the special case, and they build what's called a binary search tree, which is going to be generally less efficient in both space and time. Not a whole lot, though. It's still not bad. But mainly the reason why you want to do a tree set or a tree map is because you need to enumerate the entire contents or some large portion in sorted order. Okay. So remember, trees mean sorted order. Okay, that's why you want to use a tree. Now the downside of using a tree is that in order to get that sorted order, you have to have the comparable interface. And you may remember from their previous chapter that the comparable interface, if you implement .compare to, then you implement the comparable interface, and that allows you to sort things. So here's a summary: HashSet versus TreeSet. Again, HashSet is the one you really want to default to unless you have a particular reason why you're not going to use a HashSet. It stores things in a hash table. It's very fast, and it can be used with any type of object. Well, either of these can be used with any type of object. Trees are stored in sorted order. That's really the only reason why you're going to want to use a tree set. So here's an example. So we have to create a new hash set. This is using the diamond operator, which I don't generally encourage my students to do because it's a shorthand for hash set string. This diamond operator here is shorthand, so for omitting the string, I prefer to have my students put string there so that they really understand what they're creating. So we're adding apple, banana, apple, orange, orange, strawberry. So notice there are a couple of duplicates. There's not going to be any error when you do those adds. They're simply not going to be added to the set. So afterwards, we only get the unique set of items. You can also use .contains to quickly look up whether an item exists, and that's using that fast hash table lookup like we were talking about. Another great thing about sets is that they're so efficient, so quick for looking up. things that you can store vast amounts of data. So one common homework people use is reading in entire books. Okay, so here we're going to take mobydick.txt. We're going to read in every single word into this new hash set. And very quickly, actually, it will spit out the total number of unique words. One of the other great things about sets is that they have what are called set operations. So you can merge two sets. You can take a look at the difference between sets by doing a remove all. You can intersect the two sets by doing a retain all. One of the downsides of doing a set operation, though, is that it actually does affect one of the sets. You have to take one set and then do a dot retain all, add all, remove all on the other set. And the set that you're operating on, that first set, is the one that's going to be modified. So before you do a set operation, you may have to copy the set. Okay, so here are those set operations here. And you can copy a set just simply by creating a new set and then passing in the old set as a parameter to the constructor. It'll make a copy for you. All right, so we're about to talk about maps. So before that, let's take a look at some PracticeIts with sets. So sets are actually not a very difficult concept, and there's actually quite a few problems in PracticeIt. I'll walk through a couple of them. Here, what they want you to do is count the number of items that are in common between two sets. So here's one set, here's the other set. The items that are in common are these four. Now, before we dealt with the before we dealt with lists, what we'd have to do, sets, what we'd have to do is manually look down one list and for each item to look through the entirety of the other list to see whether it was in it, and then we could add it. It's a very expensive operation. So with sets, we now have set operations. And remember, we were just talking about how you can intersect two sets. So what you're going to want to do is make a copy of a set, and then you can intersect one set against the other without affecting the original sets, and then you can see how big that set is. Or you can create, you can use the two sets, you can iterate through the two sets and see whether one element is contained in the other, so you can just do a loop through that. There's several different ways of doing this, but it's fairly straightforward. In this problem, you're going to take a set of strings and you're going to return the length of the longest string. I would encourage you to do this with the for each loop, which internally uses the iterator, so you could do either way. And you can just look through all of the strings in the set and get the longest one. Now remember that you cannot index, you can't use a for loop and try to get the index of set members. You can't do that. You can only iterate through them. This problem is similarly simple. You're just going to need to iterate through the set and then test each one to see whether it's odd or not and return that amount. This problem is another good one where you're going to need to remove all the strings from the set that are of even length. So while the previous problems I've been talking about using the for each loop, here you can't do that because you're going to be removing items. And since you're removing items, you have to use the iterator. And again, the iterator actually, for each is actually implemented using the iterator, but because for each hides the actual iterator variable, you can't do the remove. So you need to do the remove on the iterator. So assuming you called your iterator IT, you're going to need to do it.remove, not set.remove. So the other topic we're talking about in this video is maps. So sets and maps are tightly related because maps actually use sets. We'll get there in just a second though. So what is the point of a map? Mainly just need to know that maps hold pairs of objects, not single objects, but pairs of objects. And in particular, the first object is called the key. The key must be unique, just like you would want a key for a lock to be unique. You don't want a ton of keys out there to open your lock. You only want one key. So the keys are unique and they are implemented with a set. Okay, that's what I was just saying. And then the objects are called values. And maps can be, it's again a parameterized data type, which means you can make a map of any two objects. So you can have a map of string and integer, or a map of doubles and strings, whatever you'd like. Another example of a good use for a map is if you wanted to build a chart of how many times each word in Moby Dick occurs. So we used a set earlier to store all those unique words as the keys. Well, we can have values that are associated with each word that are an integer that stores how many times we see something. This is a different example than Moby Dick, but this is an example of having student IDs. Obviously, they would be longer than one single digit, and then you would have student names. So you can have a map from integer to string here. So map methods. You can clear the map. You can check whether the map contains a key. This is an extremely useful one. So if you are trying to check whether some item exists in a map, you're typically going to be looking for the key because the keys are unique. Now you can also look for the value. There are certain reasons why you would want to do that, but of course remember that there can be multiple occurrences of a value. So for example, if I wanted to see what the frequency occurrence of a particular word like John is in that Moby Dick example I was just talking about a little bit ago, so I would look for John in the contains key, and then I would get the value associated with John. But if I wanted to find all the words that happened 5 times, then what I do is I check contains value 5, and that would be the use for that. The most important one is probably get. So you're going to produce call that Moby Dick one. You would call it .get on John and see whether there's a occurrence of John in there. You can check whether the set's empty. Key set is an extremely important one. So when you want to check to see if something exists in another set, I already talked about using contains key, and that's usually what you want to do because you're just looking for one key. But what if you want to do a whole bunch of checks on various keys, or even better, do a set operation on the keys? Then you're going to want to get the key set here. Another important note is similar to how I talked about set operations will affect the original set. When you get the key set out of a map and then you operate on that set will actually change the entire map. So not only will it change the keys, the set, but it'll also change the values of the map. So if you're looking through Moby Dick and you get the key set for Moby Dick, and then you remove a bunch of words out of that key set, those words are going to be completely removed from the set, from the map, both the keys and their values. Okay, instead of an add, they use put, and put requires both the key and the value. You can put a bunch of them from an entire map. You can remove an item, but again, remember, if you're doing if you're trying to do a for each and you're trying to remove something, that's not going to work. You're going to want to do an iteration on the key set instead. Also note that you cannot iterate on the map itself because you could be iterating over the keys or you could be iterating over the values. So generally what you're going to want to do is get the key set and then iterate on that. You can get the size, and you can also get a collection of all the values in the map. And again, there may be duplicates in this. It's not going to be a set because there could be duplicates. So here's an example of creating a map. So it's a parameterized data type, so you have to declare a map with the 2 data types that are going to be the keys and the values. So in this case, integers are going to be the student IDs, and the strings are going to be the names of the students. And so this again, this whole thing here, the map plus the parameterized data types, that's all the data type, okay? It all goes together in one thing. And then we have our variable name equals new hash map. And again, this is using the diamond operator, which I don't really encourage people to do. But one of the reasons that I don't encourage people to do it, because I just said it's this full thing, map with integer and string. That is the data type, right? So when you start doing this, you start disassociating that that's an entire data type. You start thinking hash map is the data type, which it's not. All right, so we put these items into the hash map, and we have put all unique keys here. And now we're going to get index number 2. And note that you can do this on a map. You can get with an index. You can't do that with the set. So you can only do it with the whole map. And I just mentioned that map doesn't have an iterator, so you're going to probably want to get the key set and then or the values and then iterate through that. So how do you look at the map? Well, there's two ways of looking at the map. You can either look at the keys or the values, and this is assuming, right, that you want to look at everything. So the keys have to be unique, and so you're going to get a setback. The values don't have to be unique. You're going to get a collection. And here's an example here. So we're going to use a for each loop for each student in the key set. Then we're going to actually just store the student. So this is really typical code. You're going to see this a lot. You're going to really get used to it. So you take the map and you do a .get on that key. That's the student ID. And it's going to bring you the name like Liam. And then you can print out the full thing from the student ID and the name. So that's how you interact with maps. And here's that code here. So this is exactly what we're talking about. We run that. It's going to print out the list of all those student IDs. So it's easy to map from key to value. You can't really map from value to key because there may be more. In this case, there are two names. Okay, so Anne goes to student 2 and Anne goes to student 6. You could actually look through the values and then, well, you really can't. You would have to look through every single key and then to see whether it maps to that value in order to find all the ones. So yeah, there's not an easy way to do that. So here's a comparison of the data types. So list, we've already talked about array list and linked lists. These are, the array list looks like just like a regular array. The linked list is a whole bunch of boxes connected together. So an array list, it's slow to search, but if you want to access an item by index, the array list is fast, but the linked list is not. Slow to add and remove arbitrary elements. So if you want to add onto the end of an array list, that's easy. If you want to add into the middle of a linked list or delete from the middle of a linked list, that's okay. Description: a sequence of elements arranged in order of insertion. It's a little bit misleading because obviously in a linked list you can insert them anywhere you want. I don't really particularly like that description. I would just say that it's a list of items, okay? So the main thing about sets is they're unique, and it allows both these set implementations to be searched quickly. There are no indices, so you cannot get on an index 1, index 2, you can't do that. This last sentence is a little bit misleading. So you cannot, like I said, get on an index 1 or 2, but you can actually get a particular item by name or something. It's quick to look up something in a hash set and still pretty quick to look up something in a tree set. Okay, so they suggest that unique words in a book or your lottery numbers, things that you know you're not going to have duplicates. That's going to be pretty typical for sets. And then maps, the big thing is it's a tuple. It's got two items. It's got a key and a value. And by the way, you're not really restricted to 2 items because they can store full objects. So let's say you need to store 3 items. As long as you only have one of those items being the key, that's fine because you can put the other 2 items into your own class with the 2 items, or the 3 items really. And so don't just think of it as 2, but it has to be at least 2 things. So hash maps and tree maps, it says that it's not a good general purpose collection. That's from the sense that you have to have 2 items, right? So that only for those uses where you've got 2 items. You can't map backwards from a value to its key. That's true. But it's a really useful thing whenever you want to store at least 2 items. Word counting, so we got words and frequencies, a phone book, we got a name and a telephone number. There's a whole lot of cases where, in fact, really the majority of cases, you're probably going to be using a map because you have some unique ID and then you have some data that you're storing with that unique ID. Okay, so this is a good, accurate description of those items, but I want to show you a different way to look at the different sets of data structures. So this book is not chart is not in the book. It looks a little bit similar to figure 11.1, which shows you the inheritance of all these different classes, but this is not inheritance. This is actually how you choose what data structure to use, and it really is probably the most important thing that you will learn in 143 because it is intro to data structures. So this is going to help you figure out what data structure to use, because someday, many months after you take this course, if you need to implement an array or a tree set or a hash set or a tree map, you can look it up very quickly. You can search for that. But if you need to know, gee, you need to create a program that's going to store this and that, and these are the restrictions on it, you can't just Google for that because that's too specific. You're not going to be able to Google it. So you need to really understand this chart. Let's go through this. Now there's a reason why all these boxes are blank. And that's because this is a little mini quiz for you. And it actually will help you understand and remember these things if you have to fill in the boxes yourself. I will go through them with you, but you need to fill these in on your own, and eventually you don't need this chart. You'll be able to think of it naturally. The first decision to make is whether you have one element of data or you have multiple elements of data, a double. And I just talked a second ago about how you can actually handle more than two, but it's got to be at least two. So if you've got at least two elements of items, then two items to store in every entry, then you need a map. And down here, the question is, do you need to access the data? Do you need to enumerate the data in sorted order? Okay, if you need it in sorted order, like you want to print out a list of everything, then the answer is yes, and you need to use a tree map. Otherwise, you're going to use a hash map. Remember, hashing is the general way that you should use it unless you need a sorted thing. Okay, so if it's a single piece of data, now we've got this part of the tree. So this box here is either going to send us to sets or it's going to send us to lists. And what's the main difference between sets and lists? It's whether or not our duplicates are allowed. Okay, so it's opposite of unique, but are duplicates allowed? So if duplicates are allowed, you need to go over to the lists and arrays. If duplicates are not allowed, then you need to come down here to sets. And it's the same box here and here. So if you need that to enumerate the set in sorted order, then it's going to be a tree set. Otherwise, it's going to be a hash set. Okay, so now we're looking at the case where you have single piece of data, but you need to allow duplicates. Okay, so this question here, if it's yes, we're going to need to go down to an array. If it's a no, we're going to be going down to lists. So what's the difference between an array and a list? Really, it's about the size. So if it's a fixed size set of data, so you know you only need 10 objects, then you're going to want to go down to an array. So is it fixed size? If so, it's an array. If it's not fixed size, you need to go down here. And now what's the difference between an array list and a linked list? So they're both list items, but it's a question of efficiency. So linked lists, you can insert things and delete things from the middle. That's the main difference between the linked list and the array list. So if you need to insert and delete items frequently, you need a linked list. Otherwise, you're probably fine with an array list. So you should generate that chart and get familiar with it. If you can walk down this tree, you can design any data structure that you need. So for this problem, we're done with covering the material really. So now we're going to take a look at the PracticeIts for maps. In this problem here, 11.12 exercise, you take a list of strings. So you're thinking, it's a list problem, but it's actually not, because what we need to do is to find out whether it contains the list contains 3 elements. So it accepts this list of strings and returns true if any single string occurs at least 3 times and false otherwise. And here's the key: use a map as an auxiliary storage. So remember we were talking about Moby Dick, where you read in the contents of Moby Dick and then you store Moby Dick with the words as being the keys and then the frequencies being the value. It's like that here. Instead of reading Moby Dick, you're just going to look at this list. Okay, so for each element in the list, you should go and put it into a map. Okay, and you should get used to seeing this kind of code where you have to build a histogram. What you're going to have to do is to check whether it contains the key. If it contains the key, then you're going to get the value that's associated with that key and then increment it and then store it back using put. Otherwise, you're just going to put 1 to start. Okay, so unfortunately that's a real common thing. It would have been nice if you could have just told Java had a function where you could just store the value if it didn't exist, or it would get the value and return 0 or something. But the problem is you never know what it is, if it's going to be an integer or a string or whatever, so they didn't let you do that. But anyways, this is good. It's going to show you how to remind you how to use for each, how to create a map, how to use contains key, and how to put things in. So there's a lot of good things to learn here. Okay, so this problem is a little bit tricky, so I'm going to actually give you some pseudocode on this. There's two different ways to do this. The first is kind of manually, and the second is kind of in bulk. So what we're trying to do is to figure out whether we always know that the key sets are unique, but we don't know whether the values are unique. So I didn't even say set because they aren't a set. Values is a collection. So in this case, the collection of these values, Miller, Camp, Perkins, they're all unique, so the answer would be true. In this case, Perkins is duplicated here and here, so that would be false. So one thing you can do is you can say for each value, if, well, we need to create an empty storage. So it could be anything, but you might as well just use a set. Okay, and if for each value, if the set has that value, return false. Else store the value. Okay, so we would come here and look at this set, and we would say Perkins. If this set that we created here has Perkins, no. Then otherwise we're going to store it. So Perkins is now in the set. Later when we come back here, when we see Perkins, we're going to say, does the set have Perkins? It does. And then we're going to return false. Okay, so that's one possible way of doing it. The other way is just realizing that sets can only store unique values. So create a empty set with the values. Okay, and you're going to learn that dot values will get the values. And the other interesting thing is that you can actually create, you can actually initialize a hash set directly with a collection. So you can actually take the values and then use that in the constructor. And then you can compare the size of the values with the new set. Okay? And let me scroll this up. So you now have created a new set. If the values, if the number of values equals the size of set, then no duplicates. If there are duplicates, then we're going to see a difference between the number of values, passed in and this set, because the set will erase any duplicates. So that's two different ways you can solve this problem. This problem involves intersecting two maps. And if you are an astute student, you may remember that there is an intersect function that we talked about. It operates on sets. And you might also remember that the sets will actually affect the maps. Java calls it the set is backed by the map. So if I take here's one map and here's the other map. If I take this map here, I can take its set. If I take this map's set here, I can intersect the two sets. That will get me the intersection between the two. Problem is that this problem requests that you only intersect to keep the items in which the values are the same. So it doesn't, let's see if I can find an example here. Here's Stephanie and here's Stephanie. So these two values are the same, but if they weren't, if the Stephanie was 79, you couldn't keep that Stephanie. So you're actually going to have to walk down the key set for one of the lists and then see if the other list contains that key Janet, which this one doesn't, but if Stephanie, again, we would check the Stephanie and then we would check the values, and only if all of that happens, then we put it into a new map that we're going to return. So in this problem, you're going to take a list of inputs, and then you're going to find the most frequently occurring integer. And it's fairly similar to a problem we did before, because you basically want to build a map with build a histogram map of the values, and then find whatever is, do a running max on those values to see whatever is the maximum value. So again, you've already seen most of the pieces of this, so you should be able to do that. So this problem has a very simple solution, but it's a challenging one to think about. You are going to reverse a map. So in this case, you're going to go from these indexes, these string integers as being the keys, to the string integers being the values. And the values here become the keys. Sometimes values can happen multiple times, like Marty here. So one or the other, it doesn't matter, will be stored as the value. So what you're going to have to do is walk down. Again, you can only walk down the key sets of these maps. Walk down the key set and then get the value and then put it into the new map that you're going to create. And it doesn't really matter which order you find these things in, because as long as it overwrites it, at least it gets it stored at least once, that's all that matters. Okay, this is the last problem I'm going to discuss, and it is a real doozy. I'll just warn you ahead of time. I'm not going to show you the code or even the pseudocode. This one involves trying to find the rarest of these occurrences here. So let's see, it's the strings whose values are integers as parameter and returns the integer. So you want to find the integer value that occurs the fewest times in the map. So it's this value here. You want to find, so 25 occurs twice, 20 occurs 3 times, or 20. So it does take a process. So you're going to have to first build a histogram, then you're going to have to find the minimum amount in that histogram, and you're going to have to return not the number of times, but you're going to have to actually return the value, the age, I guess it is. So there's a bunch of things to do there. I wouldn't be surprised if you find it challenging. Don't be surprised. One last thing I wanted to mention, going back to this slide where I was talking about how you iterate through a map using the key set. So this is the way the book teaches, and it's a very good way to teach it because it doesn't teach a lot of different data structures. You just need to know maps and sets. There is an alternative way which we do not teach, using something called a map.entry and an entry set. But again, it's really beyond the scope of this course. I think you're just learning extra stuff if you want to do that. So I would just say stick with using the key set. You can get all your work done using the key set. If you feel like you're really advanced, then you could go and learn the map entries on your own. So thank you very much. If you found this video useful, please like and subscribe. And of course, go and take a look at all the other rest of the videos that I've made for this course. It does provide a full college course education.